What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A Plus 1201 certification exam. So let's get into it. In today's hyper-connected world, wireless networking is no longer a luxury. It is a necessity. From Wi-Fi in coffee shops to Bluetooth headsets and RFID-enabled inventory systems, wireless technologies, they power much of our daily digital lives. And as an aspiring IT professional preparing for the CompTIA A Plus exam, understanding wireless networking technologies is essential. In this video, I'm going to walk you through all the critical components of wireless networking that you need to know to help you ace the CompTIA A Plus exam. So with that being said, let's go. All right, so first off, what is a wireless frequency? Well, wireless frequencies, these refer to these specific radio waves that are used to transmit data between devices. In different frequency bands, they offer varying benefits in terms of speed, range, and resistance to interference. So let's start off with the 2.4 gigahertz frequency, and this is the oldest and most widely used band in Wi-Fi networking. Its pros, it has a longer range, better penetration through walls and obstacles, and it is compatible with older devices. Its cons, it's prone to interference from household devices like microwaves, cordless phones, and Bluetooth gadgets. It has slower speeds compared to higher frequencies and fewer non-overlapping channels, where it only uses 3 in the US. And the typical use cases are it is great for basic web browsing, email, and general connectivity in larger areas. Next is the 5 gigahertz band, and this offers a significant upgrade in performance and efficiency. Its pros, it has faster speeds, less interference due to more available channels, and more non-overlapping channels with 23 in the US. Its cons are it has a shorter range and it has poor penetration through walls. Now, the best use cases are it is ideal for high bandwidth activities like video streaming, online gaming, and voice over IP. And then we have 6 gigahertz, and this was introduced with Wi-Fi 6E and the 6 gigahertz frequency. This is the newest and least congested band. And its pros, well, it is extremely fast. It has low latency. It has a large number of non-overlapping channels, up to 59, and it has minimal interference. Its cons, it has the shortest range. It is limited Wi-Fi 6E in newer devices, and it has limited adoption as of now. In its use cases, this is perfect for enterprise environments, augmented reality, virtual reality applications, and future forward smart homes. All right, so let's move on and talk about channels as far as regulation, selection, widths, frequencies, and bands are concerned. Well, first, let's start off with what is a Wi-Fi channel? Well, a Wi-Fi channel, this is a smaller slice of a frequency band. And routers, basically, they transmit data on these channels, and proper channel selection, this can reduce interference and improve network performance. Now, when it comes to regulations, different countries, they have varying regulations on which channels can be used. So in the United States, you have 11 channels in the 2.4 gigahertz frequency. They got 45 plus in the 5 gigahertz and 59 in the 6 gigahertz. In Europe, you have up to 13 channels in the 2.4 gigahertz frequency range. And in Japan, they allow all 14 channels in the 2.4 gigahertz frequency range. And understanding regional regulations, this helps ensure compliance and optimal setup. And then there's channel selection. So routers, they can select channels automatically or allow manual configuration. So when it comes to auto selection, basically the router scans the environment and picks the least congested channel. When it comes to manual selection, well, administrators, they can choose specific channels to avoid overlap with neighboring networks. And the best practice is you want to use non-overlapping channels like channels 1, 6, and 11 in the 2.4 gigahertz frequency band to minimize interference. Now let's talk about channel widths. So we have what is called the 20 megahertz channel width, and this is standard for 2.4 gigahertz networks, where it offers less interference but slower speeds. You have 40 megahertz. This offers more bandwidth, but it has a higher risk of interference. And then you have 80 and 160 megahertz, and this is using 5 gigahertz and 6 gigahertz bands for ultra fast connections. So essentially, when it comes to channels, wider channels can support higher throughput, but they are more prone to interference. And then we have what are called frequencies and bands. Now, frequencies, these represent the center point of each channel. So as an example, channel 1 on the 2.4 gigahertz frequency, its center point will be 2.412 gigahertz. Then when it comes to the bands, these are groups of channels, so 2.4, 5 gigahertz, and 6 gigahertz. Essentially, selecting the right band and channel based on your environment, this can make a big difference in your overall performance. All right, so let's go ahead and talk about Bluetooth real quick. So, Bluetooth, this is a low power, short range wireless technology that's primarily used for connecting peripherals. And its key features are it operates in the 2.4 gigahertz frequency band. Its range can vary from 10 meters, which makes it a class 2, all the way up to 100 meters, which makes it a class 1 Bluetooth. And it supports both point to point and mesh networking. And its common use cases are it supports wireless headphones and earbuds, smartwatches and fitness trackers, wireless keyboards and mice, and file sharing between mobile devices. And some of the versions and advancements are you got Bluetooth 4.0. This introduced what is called Bluetooth Low Energy, and you got what is called Bluetooth 5.0 Plus, and this improved range, speed, and data broadcasting for IoT or the Internet of Things. So basically, Bluetooth is everywhere from cars to home automation, which makes it crucial for technicians to understand this technology. All right, so moving on your screen, what you're looking at right now is the 802.11 standards for the evolution of Wi-Fi. So the IEEE 802.11 family of standards, this defines how Wi-Fi works, and each standard brings improvement in speed, range, and capacity. And as you can see on your screen right here, here is a chart that I put together showing you the standard, its frequency band, its maximum speed, and its key features. So go ahead and get a screenshot of that and get it in your life. All right, next, let's quickly talk about Wi-Fi 6 and Wi-Fi 6E. So Wi-Fi 6, which is also known as 802.11ax, this delivers better performance in dense environments like stadiums and offices. You have what's called Wi-Fi 6E, and this extends Wi-Fi 6 capabilities into the 6 gigahertz spectrum for more bandwidth and less congestion. And as a technician, knowing these standards will help in recommending, configuring, and troubleshooting wireless networks. All right, so let's move on and talk about NFC or near field communication. So NFC, this is a short range communication method used for data exchange between devices placed close together. And its key characteristics are it operates at the 13.56 megahertz frequency. It has a maximum range of about 4 centimeters, and it has an extremely low power usage. And its use cases are, it is used for contactless payments when you're using things like Apple Pay and Google Pay. It can be used for access control, like using it for a hotel room key card. You can pair Bluetooth devices with it, and you can share small files or data snippets. Now, NFC is essentially an evolution of RFID with a focus on two-way communication, making it ideal for quick and secure interactions. And speaking of RFID, or radio frequency identification, this uses electromagnetic fields to automatically identify and track tags that are attached to objects. So how does RFID work? Well, you have what is called a reader, and this sends a radio signal. And you have what is called the tag, and this responds with a unique identifier. Now, the tags, they can be passive, which means it has no battery, or it can be active, which means it is battery powered. And the frequency bands that are used, you have low frequency, and this operates at 125 to 134 kilohertz. Basically, it has a short range, and it's only good for access control. You have high frequency. This operates at 13.56 megahertz, and this is used for smart cards and NFC. You have what's called ultra high frequency, and this is 860 to 960 megahertz, and this has a longer range and faster data transfers. And the best use cases for this are inventory management, retail and asset tracking, livestock identification, and toll collection systems. So RFID, this is a foundational technology in logistics and supply chains, making it vital for IT professionals in various industries. Understanding wireless networking technologies, this isn't just for passing the CompTIA A+ exam. It is essential knowledge for anyone entering the IT support field. From installing wireless routers to troubleshooting connection issues, this knowledge will come into play repeatedly. And some study tips to help you get all this down packed, you want to use some flashcards. And this is especially helpful for memorizing the 802.11 standards and frequency ranges. If possible, you want to get some lab practice where you can go out there and set up a wireless router, change the SSID, adjust the channel width, and experiment with band steering. You want to do some real world observations, like you can check the Wi-Fi settings on your own devices to see how different bands and channels are used. And also, if possible, you want to get some practice exams in your life where you want to take quizzes that mimic real world scenarios involving Bluetooth, NFC, or RFID. All right, so let me go ahead and wrap all this up. So here's what we learned today. Frequencies. You got the 2.4 gigahertz, which is long range. You got 5 gigahertz, which is high speed. And you got 6 gigahertz, which is the next generation performance. We also talked about channels. So proper selection, this minimizes interference and can boost performance. We talked about Bluetooth, and this is widely used for peripheral connections and short range communication. We talked about the 802.11 standards, where each new version brings better speed, range, and efficiency. We also talked about NFC, which is a secure, ultra short range technology for payments and access. And we talked about RFID, which is versatile and widely adopted in tracking and identification. Now, by mastering these wireless networking technologies, you'll not only be prepared for the CompTIA A+ 1201 exam, but you'll also build a strong foundation for your future in IT support and networking. Now, with that being said, let's do some check on learning. So which 802.11 wireless standard operates exclusively in the 5 gigahertz frequency band and supports a maximum theoretical throughput of up to 3.5 gigabits per second? Is it 802.11n, 802.11ac, 802.11g, or 802.11b? And the correct answer is 802.11ac. All of this information was on that chart that I told you to take a screenshot of. So the 802.11ac, this operates only on the 5 gigahertz band and supports high throughput with theoretical speeds up to 3.5 gigabits per second, depending upon the channel width and number of spatial streams. 802.11n, this supports both 2.4 and 5 gigahertz. The 802.11g and B, they operate only in the 2.4 gigahertz range and have much lower maximum speeds. Our next question is, a technician needs to minimize wireless interference from neighboring networks. Which channel setting on the 2.4 gigahertz wireless network should be used to achieve this? Would it be channels 1, 6, or 11? Channels 2, 7, or 12, channels 36, 40, or 44, or channel bonding on all available channels? And the correct answer is it'll be channels 1, 6, or 11. So on the 2.4 gigahertz band, channels 1, 6, and 11 are non-overlapping and reduce interference from adjacent channels. Now, using overlapping channels like channels 2, 7, or 12, this can cause interference and performance degradation. Channels 36, 40, and 44, these are used for the 5 gigahertz band, and channel bonding on the 2.4 gigahertz, this can cause more interference if not used properly. And our final question is, which short-range wireless technology is best suited for contactless payments between mobile devices and terminals? Would this be RFID, Bluetooth, infrared, or NFC? And the correct answer is NFC, or near field communication, and this is commonly used for contactless payments requiring close proximity, typically less than 4 centimeters. RFID, this is used in asset tracking and access control. Bluetooth, this offers a longer range of up to 100 meters for some devices and is used for file transfers, audio, and peripherals. And infrared, this is an older technology and not typically used in modern mobile payments.